In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. Are there planets beyond our solar system? It's a question few had dared to probe.
The origin of hunting for planets started really from the lunatic fringe of science.
Now hundreds of these exotic worlds have been found. Could any of them be home to alien life?
Right now, the sort of planets we're discovering are kind of monsters.
You would be incinerated immediately before you had a chance to really sort of groove on your surroundings.
But some planets hold more promise.
I'm so excited about Gliese 436, I'm almost jumping out of my clothes.
Could we be on the verge of finding another Earth?
We still don't know whether our Earth is a commonly occurring planet or a 1 in a billion freak.
Cutting-edge science, strange worlds, and wild weather as we travel the universe in search of alien planets. Lurking in the constellation Pegasus, 50 light-years from Earth, is a monstrous planet. A superheated gas giant almost as massive as Jupiter, whipping around its star in a little over 4 days. It's called 51 Pegasi b, and in 1995, it became the first planet detected orbiting an alien sun. It was a landmark discovery, but just a stepping stone on an even greater quest to find a planet that looks more like our own. The ultimate but elusive goal for astronomers is to find another Earth.
What we're after is the appreciation of where our Earth fits in the grand context of our universe, and we'd love to be able to find other Earths. But Earths are so undetectable, little chunks of rock that don't emit much light.
How common might Earth-like planets be in the universe? Even if only 1% of all stars were circled by a planet like our own, that would still mean there are billions of other Earths waiting to be discovered.
We are almost sure that rocky Earth-like planets exist in abundance out there. But how Earth-like? There are still open questions about the uniqueness of our Earth. And we don't know whether our Earth is unusual or not. It's an extremely profound and, I think, disturbing question.
In the realm of alien planets, there's a wide range of imaginable worlds. We might find ocean worlds, completely covered in water. Frigid ice planets. Mars-like worlds, but perhaps with thick atmospheres, fed by massive active volcanoes. And even planets with 2 suns in their skies. There may be planets that humans would find hospitable, and others on which humans wouldn't dare tread, that could still be home to other types of creatures.
Perhaps the major lesson we've learned so far from looking for planets around other stars is that nature can make a lot more planets than we can dream of.
Finding just one other truly Earth-like planet would hint that Earths are common in the universe. And if Earths are common, then perhaps life too is widespread. But of the over 200 alien planets detected so far, most of them seem utterly hostile to life as we know it.
So far, we've found sort of 3 kinds of worlds. One kind are the planets that are really close to the star that they orbit, and they're totally baked to death. Then there are the ones that are quite far away, and they're pretty cold. And then there are the ones in the highly eccentric orbits, which sometimes get close to the star and sometimes far away. So they're alternately very hot and cold. So far, we definitely haven't found any worlds with jungles and forests. Indeed, we haven't found any worlds that are square smack in the habitable zone where there's liquid water on the surface and other nice conditions.
Our frame of reference for what we consider to be a nice planet is this one. We like it quite a bit. We've got breathable air, it's a pleasant temperature, and there's water. And even in our own solar system, we don't see a lot of planets like that. And right now, the sort of planets we're discovering are kind of monsters. In other words, they're extremes.
So is the Earth, with its rocky surface, oceans, and abundant life, just a planetary wonder with no close kin in the cosmos? The early discoveries of alien planets have yet to answer that question, but they have brought legitimacy to what once seemed like a futile quest. While many believed there had to be other worlds out there in the vastness of the universe, locating them was widely considered beyond the reach of modern science. Only a few decades ago, an astronomer hunting for these so-called extrasolar planets was taken about as seriously as someone searching for UFOs.
The search for planets as it started in the 1980s and 1990s was considered off of the beaten track of standard science.
In the early 80s, astronomer Jeff Marcy's career was going nowhere. His research into the magnetic fields of stars had reached a dead end, and he was beginning to question his own abilities as a scientist.
When I first began thinking about looking for planets, it was in a time in my career when I thought it was over. I thought there was no hope for me as a scientist, and I thought the best shot I had going out in flames was to try an experiment that everybody thought would never work, namely looking for planets around other stars. And most people thought we would never find any planets.
Before Jeff Marcy, his collaborator Paul Butler, and a handful of pioneering astronomers around the globe could begin the search for alien planets, they had to first perfect methods for finding them. Stars are easy to locate using conventional telescopes, but to find a planet takes some ingenuity and patience. Unlike the stars they orbit, planets are small and emit very little light. Even the giant of our solar system, Jupiter, is 1,000 times less massive than the Sun and 10 billion times fainter.
A huge difficulty in taking a picture of a planet around a star is that the planet is extremely, extremely faint compared to the star. The star is so bright it almost completely obscures the much, much dimmer planet.
Blinded by starlight, planet hunters realized that even if they couldn't see a planet directly, they should still be able to detect its gravitational effect on the star it orbits. A star with no planets should drift smoothly through the sky, while one with planets should exhibit a telltale gravitational wobble.
We often say that planets orbit the sun or other stars, but that's not exactly true. The planets and the stars orbit their common center of mass or center of gravity.
And this center of mass isn't halfway between them. Just like on a seesaw, the more massive object must be closer to the center of mass to bring balance to the system.
So consider the Sun and Jupiter. The Sun is about 1,000 times more massive than Jupiter.